How's it going? Today we're going to look at 5.3 bisectors in triangles, and it's really using the same things we learned in 5.2, the angle bisector and the perpendicular bisector. But when we were doing those, we were kind of just talking generically. Now we're going to stick those in a triangle, not just a random angle, but within a triangle. And what happens with these is if you were to put, like if you were going to do an angle bisector in a triangle, well, there's 3 different angles, you could do that too. And if you did all 3 angle bisectors, they end up intersecting at one single spot. And that's going to happen even on our perpendicular bisectors. That one specific spot where they all intersect is called a point of concurrency. That's this phrase right here, point of concurrency, the point where all 3 bisectors will intersect. If we are doing perpendicular bisectors, the name of that point of concurrency is called the circumcenter. If you're doing angle bisectors, it's going to meet at a different place, and that's called the incenter. So let's start with the circumcenter. Now, this particular construction, or this, if you look at this triangle, it looks really messy. Like there's a lot going on there. But here's what happened. Let me try to clarify it a little bit so you can see it, and I'll probably end up erasing some junk. And if you look at this right here, you can see is a perpendicular bisector. They've made it kind of short. We would make it probably typically longer than that. There's my perpendicular bisector. You can see the right angle. You can see the 2 legs the same. And then over here, this one is the perpendicular bisector. And right here, this little guy is a perpendicular bisector. And all of those lines intersect at this spot P. That P is called the circumcenter. That's where they all intersect. And what's kind of cool about the circumcenter is that when you measure to the each one of the vertices, when you measure over here to B, that distance will be the same as if you go over here to C, which would actually be the same as if you go to A. If you can find the circumcenter, all of those distances to the vertices are exactly the same. Now, because that distance is the same, and so in this picture here, we've kind of gotten rid of the perpendicular bisectors and just jumped in and put the circumcenter there, knowing that then the distance to each of those vertices is the same, what you can actually do is create a circle, and we say that we circumscribe the triangle. We draw a circle all the way around the triangle, and it's going to hit all of these vertices. Because I would take, if I were to do this with a compass, I would take the point of my compass and put it here, stretch it to one of the vertices, and make that as my radius. When I draw that, it's going to hit all those vertices. And that's called circumscribing the triangle. Now, when you're doing the circumcenter, you have options on where it might land. If you have an acute triangle, and for it to be an acute triangle, that means all 3 angles in the triangle are acute angles. If that's what you have, that circumcenter is going to land in the inside of that triangle somewhere. But if you start messing with that, and let's say your acute triangle is now a right triangle, that circumcenter actually will land on the edge, on the hypotenuse of your right triangle. It'll land right there. And if you get it even fancier and make that triangle an obtuse triangle, that means you have just one obtuse angle in your triangle. Then when you draw all the perpendicular bisectors, the circumcenter actually ends up outside of your triangle. All of those are possibilities. All right, let's look at this on a graph. It says, what are the coordinates of the circumcenter of the triangle with vertices, blah, 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 blah. All right, let's plot those points. A is at 2, 7. Put a dot there on your graph. B is at 10, 7. That's right here. And then C is at 10, 3. And then those 3 points create this triangle. Let's go ahead and draw the triangle. Now, if I want to find the circumcenter, that means I need to find the intersection of the perpendicular bisectors. All right, so I've got to put 3 perpendicular bisectors in there, and they're going to intersect in one spot. Now, I'm going to keep my life simple here, and I'm going to do the horizontal and vertical lines. If you look at this horizontal line right here, and I want to put a perpendicular bisector there. Well, it is 8 units long, so the middle of it here would fall there, and I'm just going to put a perpendicular bisector right there. I'll make it blue. This is the perpendicular bisector of that side. Now let's come over here on the right, on this one. This one would be easy too, because it's only 4 units long, so the middle of it is at 2. And then I'm going to make a perpendicular right through there. Oh, and look at where they intersect. They intersect right here at the midpoint of that one. And if I were to draw this perpendicular, it would go just like that. And I've found my circumcenter. It's right there. I have to write that ordered pair. That looks like I'm over 6 and up 5. And that should match on our previous slide. Remember when we had a right triangle that the circumcenter landed on the hypotenuse right there in the middle? Okay, we talked about that. Right, so now let's talk about some constructions. It's going to be kind of messy to make these. I'm just going to forewarn you. It's going to turn into a mess. That's all right. I know what I'm looking for when I'm grading it. So what we're going to do is we're going to construct the circumcenter, which means I've got to get 3 perpendicular bisectors in there. I'm going to do this kind of in different colors to help you, but ultimately you have to do 3 perpendicular bisectors. I'm going to do it on this side right here. So I put my point right here on the left, open my compass over halfway, put in my arc above and below. Now put the point of your compass on the other side, arc above and below. And then I'm going to draw in my perpendicular bisector. It goes like that. Okay? Now you can pause the video and do yours and then come back. I'm going to now do another side. I'm going to start here, open my compass over halfway, do an arc above and below, then put the point on the other side, arc above and below, and draw in your perpendicular bisector. Now I'm totally freehanding this, so forgive me if it doesn't come out exactly right. Okay. Last one. I'm going to put the point of my compass here and open over halfway, arc, arc. Now put it on this vertex, same arc, and then draw in. And you can see, look at the mess I've got. And I have colors. You're just going to be doing it with a pencil. It's going to get crazy on you, I promise. So keep track of what you've done right through there. There's my 3rd perpendicular bisector, and I've got it. Now you do have to do 3 of them. Even though ultimately 2 of them designate that point, I'm going to be looking at your 3rd one to see if it really intersected what it was supposed to, or if it made a little triangle in there where you were off on something. So I need all 3 of those plotted so I can check that. Now one of the things they do ask here at the end, they say, and then make the circle that circumscribes the triangle. So ultimately, once you have this nice circumcenter created, then you take your compass, open it up over here to this, to any of the vertices really, and that's going to be your radius. You should be able to make a nice triangle or a nice circle that goes around and hits. Ooh, see how nice my circle is? Yeah, it's supposed to hit all of those vertices, and it's supposed to look like a circle. Okay, let's move on. Here we go. Let's talk about the incenter. Now, the incenter is the point of concurrency for all the angle bisectors. So when you look at this picture, and again, it gets pretty messy, but they've done an angle bisector right here and just drawn it on. Angle bisector, angle bisector. And it creates this point right here at point P. That's called the incenter. That actually lands someplace different than if it was the circumcenter. And the angle bisector, the neat thing about it will always be the same distance to the side. And they drop it, you know, the distance to the side can vary depending on where you're going on that side. Are you going way down here or what? Well, we want the shortest distance to that side. That will always be the perpendicular distance. That's why you see that little right angle. If you go perpendicular to that side, perpendicular to this side, and straight down there, those measurements will always be the same, if that's the incenter. All right, so a couple things about the incenter. Because that distance is the same, instead of drawing a circle that goes along the outside of the triangle, we can inscribe a circle and measure out that radius there, and then that radius should be consistent all the way around, and you can inscribe a circle. When you construct or find your incenter, it actually will always be on the interior. Remember that the circumcenter was sometimes on in the triangle, sometimes it was outside the triangle. Doesn't matter what your triangle looks like, the incenter always ends up on the inside. So let's do some stuff with this, all right? This is kind of your typical angle bisector picture. You can see right here, there's an angle bisector. And then right here is an angle bisector, and those two hit at Q. So Q is my incenter. They didn't even bother to put the one over here in there, but Q is the incenter. And then if you can look and see what's the same, it's those to the side, that perpendicular to the side. So QN will be exactly the same as QO, which will be exactly the same as QM. And if you look at what they've given us, they gave us QN and they gave us QM. QN, QM, they should be equal. Let's set them equal and do some algebra. 5x plus 36 should end up equaling 2x plus 51. Subtract the 2x. Subtract the 36. Did I do that right? That's a 15, that's what it is, sorry, 15. I was going to say, that wasn't going to divide nice. So x is 5. Now the question though, got that, but the question is, what is QO? QO is this one. Well, QO should be the same as QN and should be the same as QM. I just need to take my 5 and plug it in for one of those. I should get the same thing regardless of which one I plug it in for. I'm going to plug it in over there on the right. That looks easy. 2 times 5, put it in right here. 2 times 5 is 10, plus 51 is 61. So all three of those segments should equal 61. I'll go ahead and designate it as QO because that's what they wanted. Now, this next question I thought was kind of interesting. It says, is it possible for QP to equal 50? So right here, QP. I don't know. QP isn't anything special. Why are they even asking? Well, the reason they're asking is because if you look at this little triangle here, it's a nice little right triangle. And QP is the hypotenuse of that right triangle. And I know that in a triangle, the hypotenuse has to be the longest. And since I've already designated all of those little yellow legs that QN has to be 61, QP has to be bigger than 61. So I'd say no to that. Must be bigger than 61. So here's our next thing, doing another construction, this time with the incenter. I think this one's a little bit easier. I'm going to construct the angle bisectors, just because there's a little bit less involved in angle bisectors. Let's start over here. I'm going to put the point of my compass at the vertex and put an arc through here. I'm creating these two intersections, so from those intersections I make new arcs out here. And once I have that X created, I draw in my angle bisector. Right, let's do it with all three sides. Put an arc through here, and from these two intersections, you do your arc out in there to get that X. Now draw your angle bisector. Right, let's try it one more time. Arc through here. From these two intersections, make my X and draw in your angle bisector. Oops, I kind of missed it there. All right, so right here should be my incenter. Now, once you have that incenter, then you're supposed to make the inscribed circle. Now be careful when you do this, you're going to put the point of your compass right here on the incenter, and it's going to be tempting to try to measure along this leg right here, but that's not the perpendicular distance. You can go shorter than that. You measure straight over to this side, right there. That's the shortest it could be. Measure that out, and then with that measurement, make your circle. Ooh, I missed that side, but it should hit. All right, so last thing. We did this activity in class, and then you had to do one of these for your homework also. It says, use the blank to find the fairest place to have our reunion. Okay, what we're going to do is we're going to pick 3 cities that we have relatives in, let's say. And so let's just go with, we've got somebody, let's say in Dodge City. Let's say we have relatives in Derby. And then let's say we have somebody up here in Concordia. I'm going to change those colors so they stand out from the blue interstate ones. So the yellow are all of my cities where my relatives are at. And I want to find a fair meeting place, a place where we all have to drive the exact same distance. So I want to find a point that is equidistant to those 3. Well, you have to look at this like it's a triangle. And if I want to be equidistant to the vertices, that is the circumcenter. We need to find the circumcenter. That is considered the fairest meeting place. So the circumcenter means perpendicular bisectors. And what we did then, and I won't go through it here because we've already done this construction in your notes, but you'll do one of these on your homework. We did it with the United States on the homework, but you're going to do a perpendicular bisector, do that construction, the thing where you do the arcs above, below, drawing the perpendicular bisector. But you have to do it with all 3 sides, and then what you're looking for after you've done it on all 3 sides, you're looking at where do they intersect. Oh, they look right here, and then you're supposed to pick where we're meeting. Looks like we're meeting in Great Bend. That's where we're going to meet, have our big family reunion. That way everybody's happy, everybody drove the same distance to get to there. All right. Hope this helped. Go do your homework.